You type an address and press enter. A second later, the page is there. In that second, 6 completely separate systems just did their job, and almost nobody knows what they are. Your computer has to find the address, open a connection, prove the site is genuine, ask for the page, and then draw it. Let us walk the whole chain. Start with the address itself. It has 4 parts. HTTPS is how to talk. YouTube is the name. .com is the family it belongs to. And the slash tells the server which page you want. But that name is only for humans. Your computer cannot send anything to the word YouTube. It needs numbers. So the very first job is translation. That is DNS. And before it asks anyone, it checks whether it already knows. Your browser keeps a list. So does your operating system. So does your resolver, usually run by your internet provider. If any of them has it, you are finished in milliseconds. If nobody knows, the search begins. The resolver asks a root server, which says, not me, but .com knows. The .com servers say, not me either, but this one owns YouTube. And that last server, the authoritative one, actually holds the answer. The address comes back, and everyone along the way remembers it, so nobody repeats that walk. The whole thing usually finishes in under 50 milliseconds. Now your computer knows where to go, but it has not said hello yet. So it does a handshake. It sends a SYN, meaning can we talk? The server replies SYN ACK, meaning yes, can you? Your computer says ACK, yes. 3 messages, and the line is open. That is TCP, and it matters because it numbers every packet and resends anything lost, so the page arrives complete and in order. UDP skips all that for speed, which is fine for a video call, but useless for a web page where a missing byte breaks everything. There is still a problem. Everything so far travels in the open. Anyone sharing that network can read it. So the server proves who it is. It sends a certificate, signed by an authority your device already trusts. That signature is what stops a fake site pretending to be your bank. Then both sides exchange a few numbers in public, and each works out the same secret key on its own. The key itself is never sent. Anyone listening sees the maths, but never the answer. That is the padlock. Finally, your browser asks for the page. And the request is just a short piece of text. A line saying get, the page you want, and a few details about who is asking. That is genuinely all it is. On the other side, your request does not hit one machine. It hits a load balancer, which passes it to whichever server is free. Those servers then talk to a cache and a database to work out what your page should contain. And that split matters. If the answer is already sitting in the cache, it comes back in about a millisecond. If it has to go to the database, that is tens of milliseconds. Multiply by every visitor and you see why almost everything gets cached. There is one more trick. Big sites copy their content to servers all over the world. So the video you are watching did not travel from the other side of the planet. It came from a city near you. That is a CDN. The page comes back as text, and now your browser has to turn it into a picture. It reads the HTML, builds a tree of everything on the page, works out the styles, decides where each thing goes, and finally fills in the pixels. Those last 2 steps have names worth knowing. Layout is deciding where everything sits. Paint is actually coloring it in. Once paint finishes, you see the page. And it is not over. That first file usually references images, style sheets, and scripts, and each one is another request. A single modern page can trigger hundreds of round trips. So that is the chain. Find the address with DNS. Open the connection with TCP. Secure it with TLS. Send the request. The server, its cache, and its database work out the answer. Your browser draws it. 6 systems, every single page load, finishing before you consciously notice. Subscribe for more computer science, explained properly.